This is going to be an introduction to using Pandas for data analysis in Python. You're going to have Python on your system. We're not going to cover that in this tutorial. If you don't know Python particularly well, then I would recommend you go to Anaconda and install it that way, because if you do that, then it will contain all the packages that you're likely to need. If you do know Python and you already have it installed on your system, then great. We're going to be using a Jupyter notebook, so make sure that you have that installed. If you have Anaconda, that will be installed anyway. Once you've got that on your system, we're good to go. I'm going to assume that you have Python installed on your system, and as I suggested, Anaconda is a good way of doing that. It's not the only way, and if you're familiar with another way and you want to use a different Python interpreter, then that's absolutely fine. I'm going to be using Anaconda for this tutorial and forthcoming videos in this series. Right, what we have here is the data that I want us to have a look at, or at least the dashboard for the data. So we're going to be looking at the COVID-19 data from the WHO. They have their own dashboard here, but we are going to be downloading the data to have a look at it from this link here. Now, we could just click on this link and download it and put it in the right folder. But we can do all of that with a Jupyter notebook. So that's what we shall do. So what I'd like you to do is open up your Jupyter notebook, however you do that, in Anaconda. Well, actually, before you do that, just create a folder somewhere where you can have these files, this data and these Jupyter Notebook files. So what I'm going to do is I've got an external drive. If we go to that, cd data, and there it is. So if you just start your Jupyter Notebook from a project folder that you can use for this tutorial, we will get going. Now, you're going to need Pandas for this. You're going to need NumPy. We're also going to be using a few of the modules from the standard library. So the first thing would be a good idea for you to do if you've never used Jupyter Notebooks before is to go to Help and go through the user interface tour. When you've done that, have a look at the keyboard shortcuts. This is quite a helpful menu here. So go through the user interface tour. And if you're also interested in, you could run this whole project from a virtual environment. I've made videos about that in the past. Do take a look at those if that's of interest to you. We won't be doing that for this one, but we might look at doing that in future projects. I just really want to make this about collecting the data and using Pandas to explore the data, and in the meantime, whilst doing that, teaching you a few things about how Pandas works. So we're going to have NumPy, Pandas. NumPy is usually imported as MP. Pandas is usually imported as PD. You will often see that. I say usually, almost always. I can't think of when it's not. Import OS, because we're just going to want to handle some of the paths for downloading the data, and the URL library, URL-lib, will also help us in being able to access websites and download content. And matplotlib inline, that just enables the Jupyter notebook to render plots actually in the notebook itself. We're not actually going to be doing a plot in this particular video, but there will be ones in subsequent videos, so it's just a good habit to get in. I just put it there by habit, really. I always put it there because invariably I will end up using it. So what have we got here? Let's execute that cell. If you have taken time to go through the user interface tour, you will know how to execute a cell. You just press Shift and Enter. That is one way, or you can just click on Run here. Now, what have we got? Well, we've got this variable called URL, and we're making that equal to the URL from where we're going to download the data. So that's the link to the data. Here we have another variable called file path. That is a variable that is going to store this new path that we're creating, because we're going to put the download in a folder called data, and in that folder there's going to be a folder called COVID, and the download is going to live in that folder. So we have to create that, and before we can create it, we have to, well, it's good practice to have a variable that contains that information. This OS library is really quite useful. It's part of the Python standard library. I'm pretty sure. I don't think you have to install it. I'm fairly sure it's a part of the Python standard library, and it's very good at handling, paths, and that's what it's intended to do, so that if you're using this script on different operating systems, it will take care of that for you. So let's execute that, and now here we're using the OS library again. We're going to make some directories. We're going to have the folder data containing the folder COVID, and that's what this is doing. And then we're going to create this CSV path. That's the path to the data that we're going to be downloading. So that's what this variable is going to give us. It's going to give us this path here plus the name of the file. So when we want to access that data, we'll be able to using CSV path. And here the URL lib request URL retrieve. We're going to this URL here, and then we're going to save what we have here to this path name here. So that's what all that is doing. So let's execute that. So now this is where we're going to be using Pandas. Are you looking to build a career in data science? If you are, then I have something that could be of great interest for you. StrataScratch.com is a platform designed to help you get through the data science interview. It has over 1,000 questions taken from actual data science interviews, and it's been built by data scientists. It covers Python, SQL, probability, statistics, and loads more. Let's take a closer look at the platform. We'll take a look at the user platform in a second. I just wanted to show you the home page, which shows you what the platform contains, because I can't take you through the whole platform. But, there are over 1,000 exercises, and these are questions that were taken from real interviews with some of the biggest data science recruiters out there. And, it covers a broad range of topics that would come up in a data science interview. And the best way to prepare for a data science interview is to do data science questions. So if we have a look at the actual platform, let's select Python questions, and you can see here we can choose interview questions, and then these are the companies where the questions are from. We'll select all there. And if we take this Airbnb question, actually this is quite an interesting one, because after you've done the tutorial that you're working through now, you will be able to answer this question. So let's have a look at it. The question is, find 50 searches for apartments in New York City and the Harlem neighborhood. Now, you're already given the data frame, so you just have to go through the data frame to return the information that they're looking for. You get a hint if you need one. They tell you what the expected output is. And then there's the model solution, and then you can look at solutions from users. You have a space here to test your code. You can run the code, and then when you're ready, you can check the solution. Have a think about this whilst you're going through the tutorial, because I teach everything in the tutorial that would enable you to answer this question. I don't recommend many products on this channel, but if you're serious about getting into data science, then I would urge you to take a look at this. And this is an introduction to Pandas, an introduction to what you can do with Pandas, and I think you'll find it very powerful once you see what it can do. And we're going to incrementally learn about what Pandas can do over the course of this series. So for example, here we have a variable called df. That stands for data frame. A data frame is a Pandas object, which, if you're not familiar with it, think of an Excel spreadsheet and what an Excel spreadsheet would look like if you had columns and rows. And that's really, if you want to visualize it in your mind, that's what a data frame looks like. Now, this read_CSV is a way of reading a CSV file into a data frame. At the moment, we're going to let Pandas take care of everything, and all we're going to put in here is the CSV path, and it will read the data in as a data frame. We've got a CSV file which will be read in as a data frame, but there are other parameters here that you can set, but for now we're not going to do that. So if we execute that now, we have done that without error. So this variable df, our data frame, now contains the data that we have just downloaded from the WHO website. So let's have a quick look and see what we've got. So we can see that there are 28,958 rows and 8 columns. We can see the columns, but we're restricted in seeing the rows. Obviously, we couldn't have 28,000 or 29,000 rows showing up here. It would take up too much space. So we can see the first few rows and the last few rows. And just by visual inspection, we can see that that is useful, but we can do so much more than that. Just notice as well that we have this here, this index here, 0, 1, 2, 3, 4. Now, this has been added by Pandas. This isn't part of the original data. Pandas has added this itself, and you can control how this works. If we take a look at the raw data now, and you can do that by clicking on the Jupyter Notebook homepage and then just double-clicking on the data here, which you should have downloaded. If you do that now, we click on this tab here. I've already opened mine. You can see that this is the raw data. It's a typical CSV file. It's got the first row of this CSV file is the column heading names, and Pandas has recognized that and made those the columns in the data frame. The first column is the date column. We don't have this additional index that Pandas has added here. And we'll look into that in future videos and the significance of the index and what it actually does and how it works and how you can manipulate that. But for now, we've just let Pandas read this in as it thinks is best. We can access the index if we want to, and the index is accessed by typing the name of the data frame, in this case df.index. And if we do that, we can see that we have this index object here, which gives us some information, but it tells us that it's an index. So the index itself is a separate object. And here, if we want to have a look at the columns is also a type of index, and we can access it by df.columns, so the name of the data frame dot the word columns, and we've saved this in a variable here, and we can have a look at that. It looks very much like a NumPy array. The data type is object because we have strings in here rather than any numeric data. And if you notice something that could be a little bit difficult when we come to manipulate some of the data in this data frame, we have this space here before these names. A space has been added, which could be problematic, but we can fix that too. So we've been able to access the index, we've been able to access the columns. What else can we do? Well, we can look at the index values, and we can return those as a NumPy array, and that's what we have done here. And we can look at the values in the data frame itself. So let's do that. And here we have all of the values inside of the data frame here presented as a NumPy array. And we can do more. We can have a look at the data types. And when we do that, we can see that half of them are objects, the other half are integers. And this tells us that we have strings here and numbers, integers for these columns here. So we can start to build up a picture of what this data looks like. Now, the next thing is we can have a look at the shape of the data, and we can see that we have 28,958 rows and 8 columns. Incidentally, if your number of rows isn't the same, don't worry about that because this data is updated daily, so that the number of rows will change. We can take a look at the top 5 entries in this data frame by using head, and that will give us the top 5 entries by default. If we wanted more or less, we can put a number in here. So if we wanted to have a look at the top 10 entries, the first 10 entries, we can just put 10 in there, and we will get that. The same is true with dot tail. If we do that, it gives us the last 5 entries in the data frame, and you can change the number by putting a number in the parentheses there. You can use info, and that will give you some information about the data frame itself. So we get information about each of the columns, and it tells us how many entries each column has and what the data type is as well. So we're slowly building up a picture about the data contained within this data frame, but we can do so much more as well. So if we use describe For the numeric columns, we will get a count, and then we will get the mean, standard deviation, the minimum value, the maximum values, and then the quartiles, the 25%, 50%, and 75% quartiles. So, that starts to give us a picture of what the data looks like. Interestingly, we have a minimum here for new cases, which is negative, and new deaths, there's a negative number there. So obviously some kind of adjustment has gone on. And, at this stage, if you were looking at your data, you might start wondering how you were going to use that if you wanted to get meaningful numbers from this data. If we want to look at a particular column, we can do that by putting the name of the data frame, in this case DF, and then the name of the column in square brackets after the name of the data frame. Now here we've had to put a space because of what we saw earlier, that the column names have some white space in front of them, and we're going to fix that soon. But if we just wanted to have a look at the country column, we can do that. And that is showing us the country column there. And another thing that's really useful that you will use a lot, we have entries here that repeat the country names because they're all taken from the same country. But if we just wanted a list of the countries contained in that column, we can have the column name and then use .unique, and that will give us the unique names and won't repeat any names. So we just get a list of the country names using that. And that's incredibly useful. So the columns then, we can access the columns by putting df.columns. You saw that earlier. So what I'm going to do now is rename the columns, but stripping out the white space. So using a list comprehension here, I'm going to say df.columns equals col.strip for col in df.columns. So if you're familiar with list comprehensions, that will make sense to you. We are going through everything in df columns with this variable col, and every time we do that, whatever value this col takes on is going to have this applied to it, which will remove the white space. And when we've done that, you will see that we've now removed the white space at the front of these entries here, which is useful because now we can access the column names with this dot notation. So before we access the name by using this square bracket notation, but now if we want, we can use this dot notation, which we wouldn't have been able to do with the white space there. And if we do that, we get the result we would expect. Okay, how do we access individual or selective rows and columns? One way of doing that, and there are several ways of doing that in Pandas, but we're only going to look at one in this video, and that's .loc. And LOC allows you to put the labels in that you want to access the information that you want. So we have df.loc, the name of our data frame .loc, and then here we have a row indexer, and here we have a column indexer. So here we can access the rows labeled 1 to 4 inclusive, and that's really important because there's another way of selecting parts of the data frame that uses ILOC, and that uses index numbers. And that is not inclusive. So we're not going to look at that today. We're just going to look at this one. But here we get the labels. With loc, we use the labels of the data frame indices, the index and the columns. So here we're going to get index number 1 to 4 of the country column. And if we run that, we get Afghanistan 4 times essentially, because we are getting the first 4 entries. Well, we're getting entries 1 to 4. We're not getting the first, which is the 0th entry. And that's why it's important to know whether you're using iloc or loc. Now, that in itself isn't particularly useful, but you can do quite a lot with it. So what if we wanted to look at 2 columns, and we put those labels in there as a list, and we can then say we want to look at the index entries 1 to 8, and if we do that, we get the results there that you would expect. But we can do a lot more. So what about if we wanted to just look at the countries, or at a specific country. So if we just wanted to look at the United States of America, for instance, well, if we put df.country equals, as a test, United States of America, and run that, we get this Boolean result that would be true for the United States of America and false in every other case. And we can use this now as a mask just to select the entries where the country is the United States of America. So if we put this test here inside of the square brackets and use that notation, we can now select just the entries where the country is equal to the United States of America. So you can see we can start to look at our data in a very specific way. What if we wanted to just see the entries where the number of new deaths was greater than 1,000? Well, we can do that by applying this test here, and we will see that we get the result where the new deaths is over 1,000. We can combine this now with .lock, and we can choose more than one result. So we can have here new deaths greater than 1,000, and we want to have a look at 2 columns. And we can do that quite easily. So now we have the country column and the new deaths column, where the new deaths are filtered for being greater than 1,000. But we can do more still. We can chain these conditions, so we have new deaths greater than 1,000 and the country code is the US, and we want to have a look at these specific columns. And if we run that now, we can see that we get just the US where the new deaths are over 1,000, and those are the results that we see. So again, we can be more and more selective about the data that we want to explore. There are a few built-in useful functions. So we have .max. We can see what the maximum number of new cases is in the US in this example, and we get the result there. The minimum number of new cases. We can sum the new cases, and that really should be equal to the maximum number of cumulative cases. And if we run that, we can see that it is. So, we can do little tests like that as we're exploring this data. What else can we do? Well, this IDX max is very useful. It will return the index number of the maximum entry in a particular column. So here we have the data frame. We're looking at the new deaths column. If we run this IDX max, 27,841, if we then want to have a look at this particular entry, we can just put it in here. So we have using the LOC method, so df.lock, and then we put df.newdeaths.id max, which is going to return this number here. And then we want to have a look at these columns. If we do that, it returns the information where the new deaths is a maximum. And also, it would be interesting to look at where new deaths was less than 0. If we do that, we can see that we have these entries here where new deaths is negative. So if you were exploring this data to do anything with it, it would be useful to know where those entries are negative, because they might influence the output that you will get if you're doing statistical tests on these, and you might want to know where those are, and you'd need to think about how you're going to deal with that. The other thing you can do, as the last thing we'll talk about in this particular video, is you can create new columns just by giving them a name like this here, and then you can make them equal to really whatever you want. In this case, we're going to work out the percentage of cases that we have today as a percentage of the total of the cumulative cases. So here we have new cases divided by cumulative cases multiplied by 100. And if we do that and take a look, you can see that's the result that we get. So I hope that gives you an idea of just how powerful Pandas is. And we've really only scratched the surface. We will return to this in the next video in this series. So that's the end of this first video on data analysis using Python and Pandas. Keep checking back on the channel, because the next one will be up just as soon as I can record it. I'll see you then. Bye-bye.